This time we're supposed to find the voltages across these two resistors by using voltage divider formula. Let me remind you that voltage divider formula looks like this. V Rx equals voltage source Rx over R total, where X is the variable. It could be 1, 2, 3, or any other number. How it works? The voltage divider formula requires you to find total resistance. Keep in mind that this formula allows me to find the voltage across any resistor in series circuit without finding the current. So in this case, we don't have to use Ohm's law to find the current and after that find voltage across each resistor. We can go straight to this formula and find voltage across these two resistors. First, we have to find R total because this formula, as I said, requires you to find total resistance. R total for the series circuit is R1 plus R2. We have two resistors, that's why we have to just add them up together. R1 is equal 19.2 kilohms plus 3.2 kilohms. 19.2 kilohms plus 3.2 kilohms is equal 22.4 kilohms. This is the total resistance for my circuit. Next, I can find voltage across resistor R1. The formula says V Rx, in this case is going to be my R1, equals voltage source times R1 over R total, where voltage source is equal 20 volts and R1 is equal 19.2 kiloohms over R total, which is equal 22.4 kiloohms. Plug in these values into your calculator and you're supposed to obtain 17.14 volts. Next, we can find voltage across resistor R2. VR2 is equal voltage source, and in this case, instead of Rx, I'm supposed to write R2 over R total, which is equal 20 volts times R2, which is equal 3.2 kiloohms over 22.4 kiloohms, which is equal 2.85 volts. As you can see, we've found voltages across the resistor without finding the current. So this is kind of a shortcut. If you want to verify that your answers are correct, you're supposed to use KVL, Kirchhoff voltage law. Remember, in the series circuit, voltage source is equal to the sum of the voltage drops across each resistor. That's why you are going to write voltage source is equal VR1 plus VR2, where VR1 is equal 17.14 volts plus 2.85 volts is equal 19.99 volts, which we can say this is approximately 20 volts. We found two voltages, we add them up, we got voltage source. Means all our answers are correct.